So in this story problem, we got a plane trying to fly at the 250-degree direction at 375 miles per hour. We got a south wind blowing this airplane at 25 miles per hour. We're going to find the airplane's resulting velocity and direction. Okay? So find the resultant velocity and direction. Okay, those will be your instructions. That's essentially what you might see as far as a problem on this standard 8.2. I can find the resultant of two or more vectors. Okay. I'm going to teach you two ways to do this. All right. First method. Well, maybe let me ask you this. What might be your idea?
Draw the first vector.
Draw the first vector.
And go up 25 from the north.
Okay. So you're drawing both vectors, right? Okay. So Caleb's basically saying draw this vector, and then from there draw the other vector, and then find the result. Which would be the red one there, right? Okay? So, that's definitely one way to do it.
Could you subtract them, like the first one from the second one?
Yeah, you could do 375.
No, because it's not blowing exactly back in your face. It's kind of a crosswind. So, because the plane is going to try to do this, while the wind's doing this. So the red one is going to be what actually happens. It's the result. Okay? Now, the picture method is my personal favorite way of doing it. Okay? Some of you will not like this method because it involves a lot of geometry, law of sines and cosines. Okay? I'm going to come back to this. But visually, this is what's going on. Okay? I'm going to come back to that method here in a minute. But I like drawing the picture so you get an idea. That's why I like the picture method too myself, because it makes sense. Visually, I can definitely see it. But this will... The component method I'm about to show you, I think, simplifies it a little bit. Okay? So, the first vector, the plane. How fast? 375. And this would be a 70-degree angle right here, correct? 180 plus 70 makes our 250. Okay. I'm going to find the horizontal and vertical components of the airplane. I'm going to find the x and the y values of the airplane vector. Okay? So, do this. How am I going to find the x component? I'm not drawing the scale. Use cosine. How am I going to find the y component? Use sine. Go ahead and do that. Okay. Cosine of 70 equals x over 375. Sine of 70 equals y over 375. Anybody got an x component for me?
128.3.
be negative, wouldn't it?
Or, yeah.
I mean, your calculator says,
Yeah.
but I mean, I'm making, so negative, okay, go ahead.
128.3.
Give me about 4 decimal places.
128.257.
2575, 2575.
25, yeah.
Okay. Well, there's our x component. How about our y component? Should be larger than that. Larger than negative.
38847.
3847.
Yep.
That's what.
Okay. Now, because we're not done with the problem, I might use all my decimal places when I'm writing it down. I just don't have room right up there to write every one of them down. Okay, but if I were you, I'm writing down a minimum of 4. I think we'll probably be safe with 4 going forward. But I'm going to go ahead and just write 4. But you might want to write them all down, Derek.
So why are they negative?
Here's the origin, right?
Yeah.
The vector's going this direction. It went how far in the x direction? A negative 128. How far in the y direction? A negative 352.
Okay.
Very important, otherwise you'll get your final direction wrong. You still can get your magnitude right, the length correct in the end, if you forget your positives and negatives, but your final direction would be incorrect. Tyler?
Are we gonna label these like x hat, y hat, like in physics or materials?
No, I'm not going to get into the physics method of labeling,
So just
but
leave
you
it-
certainly can. That's not going to, I mean,
Just leave them as an order pair.
yep, yep. Okay, so this represents the airplane, what the airplane's trying to do, right? Okay, now let's go get the wind. In fact, this one should be easy. And I shouldn't need to draw it, but I can. Okay, I'm going to draw it separately. What's the wind doing?
25 miles an hour from the south.
Blowing 25 miles per hour from the south, so the force is actually going to make our arrow
On the west.
straight up, right? So this arrow would represent a south wind, and I said it was at 25 miles per hour, so this one's going to be easy. What's going to be the ordered pair that represents the wind?
025.
025, yep. Everybody okay with that? Because the wind is not blowing any part of the x direction. It's blowing the airplane straight north, 25 miles per hour. So that is our wind vector as a ordered pair. Okay? So I got what the plane's doing, I got what the wind's doing. The resultant is the sum of those two vectors. So really, I've just made this problem become exactly like the problem that I gave you at the start of class. All you're going to do is you're going to add your x's together, add your y's together, and then find the magnitude and direction. Okay? So I can probably do, let's see, negative 128.2575. Negative 128.2575. And then if I take this and add it to this, is that a negative 327?
Yeah.
Yeah.
Right? Negative 327, 3847. Okay? So there's my resultant as an ordered pair, as an x and a y, but I don't want it as an x and a y. What am I going to want?
Magnitude.
Magnitude and direction. So what I would probably do is I would probably draw a picture. I know this is my x, negative 128.2575. I know that is my y, negative 327-ish, 0.3847. So I know my x, I know my y. How do I find my magnitude? Pythagorean theorem. How do I find my direction? Inverse tangent. Okay? So let's do that real quick. Could you really ignore the negatives on the inverse tangent and the Pythagorean theorem? Yeah, you really can. Using these rounded to 4 decimal places, I got about 68.6 for my direction. Did anybody use all of the decimal places in their work? Anybody in here use all the decimal places? Did you also get 68.6, or are we slightly off for the direction? Or have you not done the direction?
Never mind, I did the decimal points for the magnitude.
Okay, I'm just wondering to see if 4 decimal places was enough for us to get an answer that's not off by a tenth, is why I was asking. Okay. So 68.6 degrees, how would I label it? South of west. Has anybody done Pythagoreans? Got the magnitude? Derek, what do you got?
351.6.
351.6. How would I label it?
Miles per hour.
Miles per hour. Again, did anybody use all the decimal places? You did?
Yeah, I got 351.6 also, and then I didn't do that.
Okay. I wouldn't mind if you got a second to let's see if 4 was enough. I'm just interested for my own. I think 4 places should have made it accurate, but anybody else questions as we're doing this? Derek?
How do we know it's south of west, not west of south?
Because when we did inverse tangent, we'd be doing it at this angle right here. So you'd be finding this value right there.
Okay, so that's
That angle right there is 68.6 degrees. So if that angle is 68.6, well, we could say that the vector that represents our resultant is 68.6 degrees south of where west is.
okay.
So since we're finding it in that part of the triangle, you can label it that and it's south of west. If you subtract that from 90, then you could label it west of south.
I got 70.0000001.
Really?
Yeah.
I find I believe we're off that far. Huh. Interesting. Alright, well, and it might not be a bad idea to make sure that you're using all the decimal places. Okay, when I make my key, I'm going to use all the decimal places. Alright? So. Okay, so there's the component method. Basically, you do each vector or each force by itself. So find the x and the y that represents the plane, find the x and the y that represents the wind, add them together to get your resultant as an ordered pair, draw the picture, do Pythagoreans, do inverse tangent, get your answer. Okay, seems simple enough? Okay. Personally, for just 2 forces or 2 vectors, okay, I prefer the picture method. Okay? But as soon as you start getting up to 3 forces or more acting on an object, then I probably prefer the component method or the XY method because the picture starts getting a little bit ugly. Okay? Let me show you the picture method. Okay? For this one, I would have probably used a picture. I'll go back to the initial picture that we drew. Okay? So, if I go back to that initial picture, I know this was 375. That's what the plane was trying to do. The wind, that was 25. Okay? Would you agree that this angle right here, from the x-axis to the blue, that was 70 degrees? Okay? By alternate interior angles, this would also be 70 degrees, right there. Because isn't this x-axis going to be parallel to this x-axis? Okay? if that's the reason I'm finding out why this, or what this is, because if I know what this is, then I know what that one is right there. It's 20. Now, I want to find out the magnitude of my resultant, correct? I have this side, I have the angle right here in between, I have that side, I have a side angle side. I'm trying to figure out this side right here. What could I use? Law of cosines right now. Couldn't use law of sines yet. But if I call this side C, I could say C squared equals 25 squared plus 375 squared minus 2 times 25 times 375 times the cosine of the angle, which is 20 degrees. So 25 squared plus 375 squared minus parentheses 2 times 25 times 375 times cosine 20. Square root that answer. C is 351.6 miles per hour. So I already got the resultant using law of cosines. Okay, it's 351.61166656. Okay, I just rounded the nearest tenth to write my answer. Okay, then direction. Okay, I got my magnitude. Direction, I'm going to need that angle right here from the x-axis down to the red, right? Well, how many degrees is it from the x-axis down to the blue? 70. So if I could figure out this little angle right here inside the triangle, couldn't I just subtract that from 70 to figure out my red angle? Let's say I call this angle A. Right there inside the triangle. Law of sines. Okay, sine A over 25 equals sine 20 over this C value. $351.6116656. So 25 sine 20 divided by previous answer. That's still on my screen. Inverse sine that answer. 1.4. So if that's 1.4, I'm going to take 70 minus that answer. 68.6 degrees. So A is about 1.4, so 70 minus 1.4, so that would be, if I go back to blue here, 68.6 degrees south of west. Okay, Dakota.
What would you do if like the wind wasn't coming directly from the south? It was going like southwest or something.
Okay, great question. Are you talking this method or the component method or both?
This method.
Okay.
Because like I understand the component method.
Yep. If the wind wasn't coming directly from the south or from the north, I would still be able to calculate this angle inside the triangle. Like let's say the wind was blowing at 130 degrees. Okay. Well, right now the wind is blowing at 90 degrees, right?
Yep.
Well, I know that if that's 70, that would have been 20 to there, and then 130 would have been another 40 degrees. So using geometry and what I know about 90 right angles, alternate interior, you'll always be able to figure out that angle in between the two sides, and then you'll start with law of cosines to figure out your resultant all the time.
Okay.
So you'll be able to figure it out. It just takes a little bit of work and a nice drawing, fairly accurate drawing. Doesn't need to be perfect, but does that make sense?
Yeah.
Okay, Derek?
Okay, so when you asked Drew to find the exact answer,
Yeah.
and you got like 70.000001, how is that possible?
I actually think he mistyped something.
No, he didn't. I did it on my calculator too. I got the same thing.
Yeah, I did the same thing, I got 7
Okay.
It's getting real.
Well, alright, anyway, I don't want to waste video time on this. I'll do it here in a second, so I'm going to shut this off. My questions on that? Okay, kind of two different methods I wanted to show you. We'll get more practice at it.